Hello students, we're going to learn section 8.2, special right triangles. Now, a right triangle will always have a right angle and 90 degree in the triangle. These special right triangles, the first one is going to be the 45, 45, 90 degree triangle. That means that two angles in a right triangle are going to be congruent. If these two angles are congruent, that means their sides opposite are congruent. So another name for this is called the isosceles right triangle. So the relationship of a 45, 45, 90 degree triangle is this is one length and this is the other length. These two lengths are equal to each other because of the isosceles triangle property. Therefore, the hypotenuse is x square root of 2. The hypotenuse will always equal, in a 45, 45, 90 degree triangle, the hypotenuse will always equal the leg times the square root of 2. So in example 1, it says find the length of the hypotenuse of a 45, 45, 90 degree triangle with legs of length 5 square root of 6. So let's take a look at the diagram here. So here's the hypotenuse because it's opposite 90 degrees. This is a 45, 45, 90. So that means these two sides are congruent. 5 radical 6, 5 radical 6. Well, to find that, remember the hypotenuse is equal to the leg times the square root of 2. So let's just remember this equation. Hypotenuse equals leg times the square root of 2. Well, substitute. What is the leg? It's 5 square root 6. So 5 squared root 6 times radical 2 is going to be 5 square root of 12. When you multiply square roots, you can multiply the inner part of the radical symbol. So 6 times 2 is 12. So you have 5 radical 12. To simplify this radical, we have to look for squares in this number. So 4 times 3 is equivalent to 12. The square root of 4 is 2. 2 times 5 is 10. So when you take the square root of 4, it is equal to 2. 2 times 5 is 10. So we have 10 radical 3. So that is the length of the hypotenuse. All right, in example 2, it says find the length of a leg of a 45, 45, 90 degree triangle with a hypotenuse of length 22. So this time the hypotenuse is given versus the leg. So here we have the hypotenuse at 22. That's the leg, that's the leg. So recall, hypotenuse is always equal to leg square root of 2. So let's just write that down. Hypotenuse equals leg times the square root of 2. Well, the hypotenuse is 22. So I substitute 22 in, equals x times the square root of 2. We're just using this formula. To get x by itself, we're going to divide by radical 2 on both sides of the equal sign. So radical 2 over radical 2 reduces to 1. So now we have x equals x equals 22 over radical 2. Now, we should not have radicals in the denominator, so we're going to rationalize the denominator, meaning we're going to make this denominator a rational number. To get rid of this radical, we're going to multiply by the same number. So radical 2 times radical 2, but we also have to multiply by radical 2 in the numerator. If you think about it, what you're really multiplying is by 1. Radical 2 divided by radical 2 is 1, so 1 times any number is itself. So this way, when we multiply by radical 2 over radical 2, we are not changing the value of the problem. We're really multiplying by 1. So now this is going to be 22 radical 2 over the square root of 4. Well, the square root of 4 is 2. So the square root of 4 is 2. 22 divided by 2 is 11. So that is our answer. The leg of this 45, 45, 90-degree triangle is 11 square root of 2. All right, so let's move on to example 3. Example 3 is asking the distance from one corner to the opposite corner of a square playground is 96 feet. To the nearest foot, how long is each side of the playground? So whenever it comes to word problem, draw what the problem is about so we could understand the problem better. So here's a square playground. So we have x, and here is the distance from one corner to the opposite corner. So now if you take a look at this closely, what we have here is we have a right triangle. So with this right triangle, this is a hypotenuse, leg, and leg. This is a 45, 45, 90-degree triangle because we have two sides that are congruent. Therefore, this is 45 and that's 45. All right, so remember, the hypotenuse equals the leg times the square root of 2. So what's hypotenuse? It is 96. 96 equals x times the square root of 2. We're going to divide by radical 2 on both sides because we cannot have we have to get x by itself. So 96 over radical 2, we have x isolated already. So we're going to multiply by radical 2 over radical 2 so we could rationalize this denominator. This is now 96 over 2 because the square root of 4 is 2. 96 divided by 2 is 48. Our answer is 48 radical 2 equals x. And when you multiply this out, radical 2 times 48 is roughly 68 feet. All right, so the next theorem is theorem 8.6. Now we have another type of special right triangle. It's called the 30, 60, 90 right triangle. So here's our 30, 60, 90-degree triangle. And the relationship in the 30, 60, 90-degree triangle is opposite 90 is the hypotenuse. It's the longest side. So we're going to name that 2x. That's the hypotenuse. Opposite 30 is x. Opposite 60 is x radical 3. So this also makes sense in what we did a week ago because we said if this is the smallest angle, this is the shortest side. If this is the largest angle, this is the longest side. 60 is between 30 and 90. X squared root of 3 is between x and 2x. So the inequality of the triangle matches. All right, so here's some things to remember. Hypotenuse is twice the shorter leg. The longer leg is the square root of 3 times the shorter leg. So here's the shorter leg. Here's the longer leg. Here's the hypotenuse. All right, so in example 4, they state the longer leg of a 30, 60, 90-degree triangle has length 18. Find the lengths of the shorter leg and the hypotenuse. So let's draw. So here's our 30, 60, 90. This is x. This is 18. And now what we have to do is we have to figure out, find the lengths of the shorter leg and the hypotenuse. Well, if you recall, opposite 30 is x. Opposite 90 is 2x. Opposite 60 is x radical 3. And that's what we learned from up here. All right, so now the longer leg is this right here. So the longer leg is 18 equals 3 radical 3 times x. To get x by itself, divide by radical 3 on both sides. So 18 over radical 3 is 18 radical 3 over 3 equals x. So that's the longer leg. The hypotenuse is 2x. Well, if we already know what x is, we just substitute this in here. So let's simplify. 18 over 3 is 6 radical 3 equals x. So now what we could do is, again, substitute this in here. So 2 times x is 2 times 6 radical 3, which is 12 radical 3. So the hypotenuse is 12 radical 3. The shorter leg is 6 radical 3. And it's all based on what they gave us at the beginning. All right, last example. A garden shaped like a rhombus has a perimeter of 100 feet and a 60-degree angle. Find the perpendicular height between the two bases. So again, let's draw. So here's our rhombus. The perimeter is 100 feet. So if we're finding the side of the rhombus, it's just 100 divided by 4 because all sides are equal in a rhombus. So now we have this picture. Here's our 60-degree angle. Here's a 90-degree angle because when we drop a distance from the vertex to the base, it creates an altitude. So now let's redraw this triangle. So now when we redraw the triangle, we have our 30, 60, 90 degree triangle. So now we're just going to, again, label everything. Opposite 90 is 2x. Opposite 60 is x radical 3. And opposite 30 is x. So this is x radical 3, x, and 2x. So now let's find out what this height is. So what we're going to do is we're going to take the hypotenuse is 25 equals 2 times the shorter leg, which is x. So what we did was we divided by 2 on both sides, so that's our shorter leg. So 25 over 2 equals our shorter leg. The longer leg is going to be radical 3 times the shorter leg. Well, the shorter leg is 25 over 2. So this is now 25 radical 3 over 2, which is roughly 21.651 feet. So that is the height between the two bases. All right, that's it.